So an aggregate walks into a bar, and the bartender says, "You look crushed." The aggregate replies, "Well, I just did the aggregate crushing value test." Now, don't let the punchline slip through the cracks. The aggregate crushing value test is no joke. It's a way to determine the relative resistance of an aggregate to crushing under a gradually applied compressive load. Think of it as a strength test for stones, but instead of bench presses and squats, we're talking about tons of pressure. And here's a fun fact. The lower the crushing value, the stronger the aggregate. So, if you're an aggregate, you want a low score. It's like golf, but with rocks. But why do we do this, you ask? Well, it helps us ensure that our buildings and roads can stand the test of time and weight, of course. It's like a fitness test for stones, keeping our infrastructures in shape and everyone safe. So, next time you're feeling a bit crushed, remember, you could be an aggregate in a crushing value test. How do you make an aggregate flinch? Just mention the aggregate impact value test. Now, this test is like the ultimate tough love for aggregates. It measures their resistance to sudden impact or shock loads. Imagine if you were an aggregate just chilling in your natural state and then BAM! You're hit with a massive force. How would you react? Would you crumble under pressure or would you stand strong? That's essentially what the aggregate impact value test is all about. Now you might be thinking, why the shock treatment? Well, it's crucial to know how aggregates will behave under sudden loads in real-world conditions. It's like a reality check for them. And here's a fun fact, the higher the aggregate impact value, the weaker the aggregate. So, it's a bit like a reverse popularity contest. The lower your score, the more everyone wants you. So the moral of the story is, if you're an aggregate, try to avoid making an impact. What did one aggregate say to the other? "You're looking a little flaky today." Well, it might have just taken the Flakiness index test. Now, the Flakiness index test isn't about checking an aggregate's commitment issues, but is a way to measure the particles that are considerably smaller in thickness than the other two dimensions. It's a test that reveals if the aggregate can stand up to the weight and pressure it will face in construction. Moving on, let's elongate our discussion to the elongation index test. This one's all about measuring the particles that are much longer in length than the width and thickness. It's like the high jump of the aggregate world, making sure the aggregate can stretch itself without breaking apart under stress. You see, in the aggregate world, shape is everything. It determines how well the aggregate will fit together, how much pressure it can endure, and how durable it'll be in the long run. Remember, folks, in the world of aggregates, it's hip to be square, or at least not too flaky or elongated. Why did the aggregate go to the gym? It wanted to work on its specific gravity. Now, let's dive into the specific gravity and water absorption test. Here's the scoop. Specific gravity is the weight of a given volume of aggregate as compared to the weight of an equal volume of water. It's like comparing an elephant to a fish in water. One's going to make a bigger splash. Now on to water absorption. Imagine going out in the rain without an umbrella. You're going to get wet, right? Well, aggregates are the same. They absorb water, and this test measures how much they can take in. It's like a sponge soaking up a spill, but with more science involved. These tests are important because they tell us how resistant the aggregate is to wear and tear, and how it might behave in different weather conditions. So the next time you're feeling a little heavy or bloated, just think, you could be an aggregate in a specific gravity and water absorption test.